All right, so I'm going to be going over this 2.6 geometric proofs worksheet. I know a lot of people have had questions about it, so I want to spend a little time here. So we are given that B is the midpoint of AC, so that's this segment here. That's going to let us know that these two pieces are equal by the definition of a midpoint. And then our second given is that C is the midpoint of BD. So that also means that this segment here and this one are equal. Notice we can actually now see that all three segments here are equal. And our goal is to prove that AB and CD are equal. Okay, so let's go ahead and get started with what this proof looks like. This one should be pretty straightforward. With most proofs, what you're going to want to do is start out with your given statements. When in doubt, list your given statements first. In fact, this is the way I would encourage you to start all proofs. B is the midpoint of AC. C is the midpoint of BD. If this were a flowchart proof, we would want to write those separately in two different boxes, but as it is, we can just put it as our first step, given. Second step here, we're going to talk about the segments that we know to be equal. So AB is equal to BC. And also BC is equal to CD. Those are both true based on the definition of midpoint. Because B is the midpoint of AC, that means these two pieces are equal right there. And because C is the midpoint of BD, that means BC and CD are equal. So those, I can use the same reason for both of those. And now, since AB is equal to BC and BC is equal to CD, we can use the transitive property to say that AB is equal to CD. Based on the transitive property of equality. So there we go. And that is our proof here. Not too complicated. There could be some other things that we do in here in terms of writing these statements with congruence instead of equal. But since we are trying to prove equal and not congruent, we don't really need to do that. All right, I'm going to go ahead and clear what I have and move down to the next proof. All right, this one is a little more complicated. I'm going to go ahead and go back to drawing on my picture. So it is given that JK is equal to MN, and L is the midpoint of KM. So L is the middle of KM. That means that this one and this one are equal. Notice I use double markings for those because these segments are not equal to those single marked ones. And we are trying to prove, I'll make this in green, JL. So we are trying to prove that JL right there is equal to LN. All right, well, based on the markings we have, it's pretty obvious. We have a single mark and a double mark, single mark and a double mark. They're going to be the same. So we're going to want to write equations for both of these segments and show that they are actually equal to the same thing. So we'll be using the segment addition postulate at some point. All right, but to start things off, list my givens. L is the midpoint of Km. So those are my two given statements. After that, we need to state that KL is equal to LN. That's something that we have not done yet because of the midpoint, because L is the midpoint. So definition of midpoint. All right, we only have some options in terms of what we want to do next. I'm going to use the segment addition postulate to write some equations. I'm going to say that JL equals JK plus KL. So that's this one right here. JL is equal to JK plus KL. I'm also going to write another equation for LN. So LN is equal to, I'm going to do it in this order, MN plus LM. And those are just looking at my picture and using the segment addition postulate. All right, now we have a few, didn't mean to change that, but we have a few equations here that I'm going to make use of. We know that JK and MN are equal, and we know KL and LM are equal. So I am going to make some substitutions. I am going to replace MN with JK, and I'm going to replace LM with KL so that we get a new equation. I don't like that to be yellow. It's hard to read. So making substitution only into my second equation. So Ln equals, so instead of MN, I'm going to put JK because those are equal. You can see that right there. And instead of LM, I'm going to put KL. Now the reason I'm doing that is now look at this. Look at these two equations right here, the ones that are next to each other. They're exactly the same on the right side. So that was using the substitution property because we were replacing things that were equal. Substitution property of equality. Now we can see very, very clearly that this equation for JL and this equation for LN are the same on the right side. Therefore, JL has to be equal to LN, which is what we are trying to prove, and that is we could call this a couple things. I'm going to use transitive property of equality. We could also say that this is substitution. Since Ln is equal to that, we could replace that with Ln over there. So you could say that this is substitution as well, depending on how you decided to express this answer. Not too complicated there. I'm going to go and draw the lines in just to make sure it's clear about where each step is. And that is our proof. A little more complicated than the first one, but not too difficult. This was about writing two separate equations and kind of putting those together. All right, and I'm going to clear that. So let's go ahead and move down to number 3. All right, looking at this problem, we're now dealing with angles. So we have angle 1 and 2 form a linear pair. That's easy to see right there. So we know those are supplementary. And angle 2 and angle 3 also form a linear pair. We are supposed to show that 1 and 3, the measure of 1 and measure of 3 are equal. All right, so that's easy enough. Those are vertical angles, but we're not supposed to use the vertical angles theorem because I'm assuming this is a proof of this theorem, or at least a case of this theorem. So I'm going to go ahead and write out my givens. Angle 1 and angle 2 are a linear pair. Angle 2 and angle 3 are a linear pair. And that is just given to us. And then next, because they're a linear pair, that means they're supplementary, right? So angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. That is our linear pair theorem. Because if two angles form a linear pair, that means they're supplementary. That means we can write some equations here. So we can do the measure of angle 1 plus the measure of angle 2 equals 180. And the measure of angle 2 plus the measure of angle 3 equals 180. That is the definition of supplementary angles. When we have supplementary angles, we can always write that. Now, since both of these equal 180, we can actually put these two things together. So we can say the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. Yeah, you could call this the substitution property. Since this equals 180, you just replace this 180 right here with measure of angle 1 plus measure of angle 2. You could also call it the transitive property. It's up to you. Depending on how you think about it, I think you could make either argument. All right, and now the last thing is, hopefully we can notice this right here. Remember, our goal is to show that angle 1 and 3 are equal. If we subtract away the measure of angle 2 from both sides, so the same value from both sides, we end up with what we're going for there. So that's what we'll do. We'll subtract measure of angle 2 from both sides, leaving us with the measure of angle 1 equals the measure of angle 3. Thus, what we were trying to prove, and we're good to go. And that is a subtraction property of equality. Not too difficult. A fairly common type of proof where we have to write a couple equations and put them together. So it's kind of similar to what we did before. We didn't make a substitution though, so maybe a touch easier. All right, let me clear this and move on to the very last example. All right, this one does not have a picture, but that's okay. We have some complementary angles. Angle M and angle L are complementary. Angle R and angle L are complementary. Prove that measure of angle R is equal to the measure of angle M. Okay, so both of these angles are complementary to the same angle L. All right, so let's go ahead and start this one. Start with the givens, right? Angle M and angle L are complementary. Angle R and angle L are complementary. That's given to us. Next, we can write some equations from that. So the measure of angle M plus the measure of angle L is equal to 90 degrees because they are complementary. Measure of angle R plus the measure of angle L is equal to 90 degrees, again, because they are complementary. So the definition of complementary angles. And since they're both equal to 90, just like the last one where they were both equal to 180, we can kind of put these together. So measure of angle R plus the measure of angle L is equal to measure of angle M plus the measure of angle L, right? These are both equal to 90, so they have to be equal to each other. And then actually we can kind of do the exact same thing that we did on the previous one. We subtract L from both sides, and we're left with exactly what we were trying to prove there. Again, this could be transitive property of equality or substitution property of equality. I think you could argue either one of these depending on how you thought about it. Measure of angle R equals measure of angle M. Subtraction property of equality. And yeah, there we go. That's what we were trying to prove. Hopefully that was helpful to you guys. Good luck on your test.